What up, my dudes? This is Mr. Gardner and this is Math Time with Mr. G. Today we're going to be analyzing data displays. So all that means is we're going to look at different ways to present data and look at the pros and cons of each data set. The first type of way that we can describe data is through a dot plot. And then the second way is a histogram. And the last one is called a box plot. Some people call it box and whiskers. And we'll talk about that why. So the first type is a dot plot. And how a dot plot works is, let's say this bottom section right here, each dot is a student on your most recent math test and what they scored. So right here, there was 2 students who scored a 66 on the math test. There was 3 students who scored an 81% on the math test. And then let's say this is someone scored a 90. So how are dot plots useful? They're good when we're talking about small data sets. So for example, like a single classroom, or in this case, a dance competition, or something where it's easy to just do 10 little dots or X's or whatever to put your data down to make sure that you don't have any bias as a judge, as a teacher. What do you need to fix? So it's easy for small things like that. It's easy to find clusters. And a cluster is a group. So like there's a group, there's a group. These guys are kind of by themselves, and this guy's definitely by themselves. So we can say, what does this group need? What does this group need? And then we can say, this student is special. This group of students is special. But these are our 2 main focuses. And that's what a cluster is saying, where is our cluster and how are we doing with that cluster? And the final thing is to find outliers. So outliers are ones that don't really fit with the group. So with this data set, it's normally things that are way outside the norm. So these are normal because there's a cluster. This is normal because it's a cluster. This is considered normal because it's in between the group. But this one's outside the group and way outside the group. So like 81 seems like normal here, and this 90 is way outside the group. So it's easy to find what's normal and what's way outside the group. What does it lack? Well, it lacks finding predictions. So if I gave you a group and said, hey, where are they going to land in this group? Well, I don't know. There's a cluster here, there's a cluster here, there's outliers. I couldn't tell you what a student's score is going to be based off of this information. It doesn't really help us predict the future. And it's hard to find frequency. So for example, how often do people score an 81%? Well, I would have to physically go count 1, 2, 3. And I'd have to do that for every single number group and count. And it's not real quick, not real efficient in that way. The next type we're going to look at is histograms. So what's the difference between a histogram and bargram? So a histogram has ranges from 6 to 7, 8 to 9, 10 to 11, 12 to 13. Whereas a regular bar graph, I would have to do every single category and graph it that way, for example. And what this is useful for is when I just want to look at ranges of data. So for example, say I just wanted to look at like elementary school, middle school, high school, college. And I just wanted to say, okay, how many high schoolers know this stuff? How many middle schoolers know it? So on and so forth. And that way I can deliver funding to the school. Another way that's really good for is huge data sets. So let's say I'm looking at high schoolers and I'm looking at 500 students. Where a dot plot, I would have to draw 500 dots. Whereas this, I can just do a bar and say, hey, this is 500 right there. It's also easy to see trends. So for example, posts per day. So we can say that most people do 10 to 11 posts on their Instagram a day. And that becomes kind of our average, and that's easy to see that few do little during this time, but a lot peak here, and then people who go down that way becomes less and less obvious. Okay? Cons is we don't have the individual data set. So on the dot plot, we could say one person scored a 67. On here, 6 to 7, I don't know who scored what and what each individual did. So I just have to look at the holistic data instead of individual data. And it's hard to see if it's skewed. And we'll talk about what skew means in a little bit, but because there's ranges instead of every single individual group, it kind of clumps everything together. So maybe we're looking at kindergarten through 8th grade in just this single bar graph. Well, that's a huge range of if someone knows something. For example, kindergartens won't know it, but 8th graders might. So by clumping everyone together, it's hard to see if the data is skewed in any way. All right, and the last one's called a box plot, box and whiskers. And the reason it's called box and whiskers is there's literally a box and whiskers like a cat. What makes this useful is to find the big five. And on the next slide, we'll talk about what the big five is. And it's easy to compare data. So let's say that this is a box and whiskers plot to represent how my students did on the test. And let's say there's a different teacher and their students. And then there's an even third teacher over here and their students. And a fourth teacher over here and their students. We can easily look at all four of them together and compare. And then the last bit is it's easy to see skew. So it's real easy to see with this box, and we'll talk about how in the next couple of slides on how it's easy to find skew. The con is that there's no individual data, just like the histogram. And we can't find mean or mode with this. Pen's freaking out. We can't find mean or mode with this, which means we can't find the average of it using this. We can find the mean only. So let's talk about what are the big five. Okay, the first one is the minimum data, maximum data, and this is going to be called Q1, which is shorthand for lower quartile. And I'll talk about what that means in a little bit. And then Q3, which is our upper quartile, and then our median, or the middle number. Okay, so above here, I have the test results for our most recent math test. So our minimum is whoever scored the worst. So this person scored the worst with a 40. And the max is whoever did the best. Well, that's this person right here with a 99. Okay? In the next slide, we'll show you how to find these three. So the first thing we do when we're doing a box or whiskers or a dot plot or a histogram is we're just going to reorganize it from smallest to biggest. So I'm just going to go through and find my values smallest to biggest. And then after I do that, then I can figure out all my other things. So my min is going to be 40. My max is going to be 99. Then I bring those in to make my box. And then my median, which is the line that goes down the middle, is I just start crossing off from both ends until I get to the middle. So 86 is my middle. This is also known as my Q2, or my median. Alright, now to find our Q1. So our Q1 is we start with the median, and then we're going to cross out until we find the median from the median to here. So I have 77. My next one is I'm going to go back from my median and cross out the opposite direction until I find the middle there. If there's two that are perfectly split, we would add these together and divide by 2. So I would do 90 plus 90 divide by 2, which is 180 divide by 2, which gets me back to 90, but that's the idea. Now, I promise I tell you what Q1 and Q3 mean. This is the first quartile of information. And the way to view this is, let's say that we're watching a football game. This is from kickoff, the start of the game, and this is the end of the first quarter. So that's what Q1 means, the end of the first quarter. And then we keep watching the game. This is the end of the second quarter. And we keep watching. This is the end of the third quarter. And then we keep watching. This is the end of the game. So this would be our fourth quarter. But what makes this useful is this box tells us that most people fit in this box, which makes sense because between Q1 and Q3, there's our data. There's only 2 numbers that are outside that data. And if I had a number line to really show it out, then you could really see how close this data is to each other. Because you would see, oh, this is only 9 away. So this is not an obscene number. But this is 37 away. And that's a lot. And so we're going to eventually learn what is a lot, what makes an outlier. So this student didn't do so well because they're 37 away from the next quarter, whereas this one's only 9 away, and that's not too far. The last thing, how does a box and whiskers show a skew? So in a perfect box and whiskers, my first quarter, second quarter, or my median, and my third quarter are equal distance apart. Just like in a football game. The time in the first quarter to the second quarter and the time from the second quarter to the third quarter should be the same. So that would be a perfect box and whiskers. It never works out that way, but that's the dream. But if I have a box and whiskers that looks like this, where Q1, median are super close to each other and Q3 is way over here, we can say it's skewed. We're going to say it's skewed to the right because there's so much more stuff on the right, which means that most of our data is down here, which means even though this is Q1 and this is our median, most of our students did bad. Whereas this means some did bad, some did good, some did okay. This means most did bad. Versus we can have a skew in the opposite direction. So there's my box. And let's say this is my median. This means that I'm skewed left, because most of this is empty on the left. And what this means is most of my students were in the upper end, which means most of my students did good on the test, which may be good, maybe not. But that's it for today. If you have any questions, leave a comment in the comments section, and don't forget to be kind to each other and ask lots of questions and think deeply.